Gaiai presents itself as a decentralized AI compute network designed to support model execution, inference tasks, and community-driven intelligence within Web3 ecosystems. The project aims to distribute both compute resources and AI models across a global node network, reducing reliance on centralized AI providers and enabling permissionless access to machine learning capabilities. According to publicly available documentation, Gaiai's vision is to build an open, verifiable, and resilient AI infrastructure that empowers developers, node operators, and users to participate in AI creation, deployment, and utilization in a transparent manner. At the core of Gaiai is its compute network, where participating nodes contribute processing power to execute inference workloads. The project describes an architecture in which tasks are routed to available nodes, models are hosted by contributors, and results are returned to users in a trust-minimized environment. This approach is intended to balance decentralized participation with the performance demands of AI workloads. The platform introduces a model sharing system allowing users to publish, update, or monetize machine learning models within the ecosystem. These models may support tasks such as natural language processing, image reasoning, data extraction, or specialized domain-specific inference. By building a shared intelligence layer, Gaiai seeks to create a marketplace-like environment for AI capabilities. The Gaiai token is positioned as a utility asset within this ecosystem, potentially supporting compute payments, model access, staking, or governance mechanisms. However, detailed tokenomics, such as supply allocation, distribution mechanics, or long-term incentive structures, are not yet fully documented. For a decentralized compute protocol, robust token design is essential to ensure sustainability, developer incentives, sufficient node participation, and protection against manipulation. Without transparent economic details, evaluating the long-term viability of Gaiai's incentive framework remains challenging. A defining element of Gaiai's goals is verifiable compute. The project emphasizes that users should be able to confirm how model outputs were generated, potentially using cryptographic proofs, reputation systems, or on-chain verification frameworks. While this ambition aligns with broader industry trends, no comprehensive technical disclosures or audited designs are currently available for public review. The documentation references future support for on-chain and off-chain verification mechanisms, but the exact methods, their limitations, and their expected performance characteristics have not yet been specified. As a result, key components of the system remain conceptual. The vision underlying Gaiai reflects a growing recognition that centralized AI production carries risks, such as data monopolization, opaque model behavior, and limited control for users. A decentralized network capable of distributing data, models, and compute power could mitigate some of these concerns. However, the technical challenge is substantial. Inference workloads require consistency, speed, high resource availability, and safeguards against malicious nodes. Successfully decentralizing such systems demands a careful balance between openness, performance, and trust minimization. Gaiai's ability to deliver a reliable and efficient execution layer will directly determine whether the network can support real-world AI applications beyond experimental use cases. Model sharing introduces additional complexities. Contributors must be confident that their models are protected, that usage is tracked correctly, and that compensation, if implemented, is distributed accurately. Consumers of model outputs must trust the consistency and integrity of responses generated by distributed nodes. Without strong validation frameworks and transparent operational logic, decentralized AI networks risk producing unreliable results or enabling model exploitation. Gaiai's future roadmap will need to demonstrate solutions to these challenges, including security, performance optimization, and governance of model updates. Despite these hurdles, Gaiai represents a compelling direction in decentralized AI development. Its focus on community-driven models, permissionless compute, and shared intelligence aligns with emerging Web3 principles emphasizing openness and user sovereignty. If Gaiai can deliver a verifiable compute network, clear documentation, and a sustainable incentive structure, it could contribute meaningfully to decentralized AI infrastructure. The project currently stands at an early conceptual stage, and its long-term impact will depend on the execution quality of its architecture, transparency around its technical development, and its ability to support real applications that rely on dependable AI inference. For more insights on Gaiai, decentralized AI compute networks, and community-driven model execution ecosystems, remember to like, subscribe, and keep learning, here at Crypto in Black and White.